Hello everyone. So today we will see about the third topic of generation. Sorry, it's fourth topic of generation. It's regarding the wind power plants. Okay, the name wind power plants. It is the generation system which converts the mechanical energy from the wind to the electrical energy. Okay, so as I shown in this particular figure, this is nothing but a windmills. Already we are familiar with this structure. We are already seen this structure in lot of areas, typically for hilly areas. So wind power or wind power energy is the use of wind to provide the mechanical power through wind turbines to turn the electrical generators. Wind power is a sustainable and renewable energy and has a much smaller impact on the environment compared to burning fossil fuels. That means what? Actually, we have seen in the first topic regarding the thermal power station. That means in the thermal power station, we are burning the combustion of coal, which produces the electricity. Okay, that means we are creating the heat energy, we are creating the steam energy through the burning of coal, and this heat energy we are applying for the water, which creates water, which produces the water into the steam, and this steam we are going to apply for the steam turbine for generation of electricity. Okay, there all the process has a different issues regarding the environment. So for this wind power station, we don't have any environmental issues or environment impact compared to any other systems. Okay, so we will see about the detailing about the working principle of wind power stations. So as I said earlier, the wind power plant is a generating station which converts the wind energy into mechanical energy first, and then later one, this mechanical energy we are going to convert into electrical energy. So on the turbine, the wind energy is applied for the wind turbine, which is directly converted this energy from the wind to the first in the mechanical, and then later one it's to electricity. Okay, so these are the basic parts of the wind power plant, we simple called the schematic diagram. So for this turbine, we are applying the wind power. Now, this due to the application of wind power, then the wind turbine is going to rotate. Okay, and now this wind turbine, it is already connected to the gearbox, generator, and as well as the different power systems. So here, what will happen? Now, as we know that the wind is always flowing from the high pressure to low pressure due to the application of sun as well as any land system. So this wind, this wind we are applied for the turbine, which is converted the mechanical energy from the turbine to the electricity. Okay, so how this phenomenon is going on, we will see later. Okay, so again, wind turbine operates on a simple principle. The energy in the wind turns two or three propeller like blades around a rotor. The rotor is connected to the main shaft, which spins a generator. Spins means rotate, spins a generator to create electricity. Wind turbines converts the kinetic energy in the wind into the mechanical power. Okay, that means firstly we are applying the whatever the kinetic energy of wind into the mechanical energy with the help of the turbine. Okay, and then this turbine is coupled to the generator through the different coupling arrangement as well as the gearboxes. So basically the turbine has maybe two blade, three blade, or four blade, depending on the application, depending on the different advantages or disadvantages. That blade number of blades of the turbine will get selected. Okay, and now in general practice we are already using the three blade system, because the three blade system has a lot of advantage compared to the two blade as well as the four blade system. Okay, these advantage limitations we will see later. So this is the schematic diagram, we call it the basic principle of the wind power stations. Now whatever the wind which is applied on the turbine, now turbine is start rotating. Okay, this wind turbine start rotating. म्हणजे ऍक्च्युअली काय होतं, हे जे दाखवलेलं आहे फिगर मध्ये, इट इज नथिंग बट द विंड ब्लेड्स. ओके, ब्लेड किंवा आपण सिंपल इन मराठी कॉल्ड टर्बाईनचे पातं. ओके, टर्बाईनचे पातं किंवा सिंपली कॉल्ड ब्लेड्स. नाव इट इज हॅव्हिंग अ थ्री नंबर्स, म्हणजे तीन ब्लेड्स ॲज्युम करून आपण स्ट्रक्चर एक्सप्लेन करतो. तर सपोज दे आर नथिंग बट द थ्री ब्लेड सिस्टम. नाव दिस विंड इज applied on particular wind blades. Now the blades are connected to this particular structure. म्हणजे हा जो पार्ट आहे, it is called as a hub. Okay, HUB म्हणजे hub. Now these blades are connected to the hub. Okay, and now this whole structure we are going to connect to the generator through the gearboxes. Why it is required gearboxes? Because as we seen, the generator always rotate at a speed of about 1000 rpm or more than 1000 rpm. That means revolution per minute. But actual wind turbine, it is not rotating that speed. So wind turbine actually it does particularly the speed of wind turbine depends on the speed of wind, okay, which is available on the nature. सो जितकं वाऱ्याचं इनपुट आहे त्या प्रपोर्शनल तुमचं विंड मिल फिरणार आहे किंवा टर्बाईन फिरणार आहे, आणि तितकं विंड टर्बाईन जर मला जनरेटरच्या स्पीड मध्ये किती असणार आहे 1000 आरपीएम किंवा 1500 आरपीएम इतका स्पीड असणार आहे. जर मला इतकं 1000 आरपीएम मला स्पीड जर अचीव्ह करायचं असेल, मला अवेलेबल किती असणार आहे इथं फक्त किती असतं तर हार्डली 10 to 15 मीटर पर सेकंड इतका विंडचा स्पीड असतो. ओके, 10 ते 15 मीटर पर सेकंड हा इतकाच विंडचा स्पीड असतो. पण मला इथे किती पाहिजे आहे, मला जवळपास 1000 ते 1500 आरपीएम इतकं जनरेटरचं स्पीड पाहिजे आहे, जेणेकरून मला इथं 11000 व्होल्ट किंवा 11 केव्ही जनरेट करता येईल. बट this speed can be achieved through the gearboxes. As we know that gearbox म्हणजे सिंपली काय, ह्याच्यामध्ये the different gears and pinion tooth and pinion arrangements are there. The input speed it can be varied depending on the applications. म्हणजे जितकं मला जसं मला स्पीड लागणार आहे जनरेटरला तितकं मला मी अवेलेबल किंवा ऍडजस्ट करू शकतो थ्रू द गिअर बॉक्सेस. ओके, आणि जनरेटर काय करणार, जसं का माझं विंड मिल किंवा जसं माझं विंड ब्लेड्स किंवा विंड टर्बाईन जसं फिरायला लागेल तसं काय होईल, सपोज इथं स्पीड सपोज मी म्हणतो की इथं सपोज एक 50 आरपीएम इतका स्पीड असेल तर काय करणार, हा 50 आरपीएम स्पीड थ्रू द गिअर बॉक्सेस हा जनरेटरला इनपुट दिलं जातं. मग गिअर बॉक्स मध्ये सिंपली काय करतात, गिअर बॉक्स तुम्हाला माहिती आहे की गिअर बॉक्स मध्ये काय होतं, इथले जे 50 आरपीएम किंवा 50 आरपीएम स्पीड आहे तो इन्क्रीज केला जातो 1500 आरपीएम किंवा 1000 आरपीएम डिपेंडिंग ऑन द रेटिंग ऑफ द जनरेटर. ओके, आणि एकदा का जनरेटर फिरायला लागला तर तो काय करतो, जनरेट इलेक्ट्रिसिटी and it is given to the grid system. Okay, now always there is a control systems are there. Control system, the basic we call the control system is nothing but the heart of this particular system. कारण कंट्रोल सिस्टम शिवाय विंड पॉवर प्लांट कधीही ऑपरेट होऊ शकणार नाही. If we are going to connect this wind station to the grid or simply called it the power system, then we should provide the control system. Okay, so we will see the detailing about the inside, what is inside in the wind blades. Okay, already we have seen about the wind turbine. Exactly wind turbine मध्ये काय असतं हे आपण इथं नेक्स्ट फिगर मध्ये बघायचं. Okay, so in that figure it is clearly shows that the working principle as well as the construction details of the wind power plant or windmills. Okay, exactly the blades are here. These are the different parts of the wind power stations. So these are the blade. Now this is the rotor. Now we can see this rotor, it is now blades are connected to the rotor. Now this rotor has a common shaft. Ha jo shaft disto, it is nothing but a common shaft which is connected to the gearbox. Okay, as I said in this figure, now this turbine is connected to the gearbox as well as this. Now this rotor blades are connected to the rotor and rotor is connected through the shaft to the gearbox. Now we can see this gearbox which is connected to the generator. Okay, now generator हा काय करणार, हा जसा gearbox जसा तुमचा blade फिरायला लागेल तसं काय होईल, तुमचा हा rotor फिरायला लागेल. rotor it is coupled to gearboxes. So as well as once the gearbox is rotating according to the my input required speed, the generator will start rotate. Okay, म्हणजे जनरेटर तुमचा रोटेशन होणार आहे आणि काय करेल, हा जनरेटर जो काय तयार झालेली एनर्जी आहे इलेक्ट्रिसिटी तो काय करेल तर डायरेक्टली थ्रू द पॉवर केबल हा काय केलं जातं, डायरेक्टली पॉवर सिस्टीमला किंवा टॉवरला किंवा आपल्या जे काही ट्रान्सफॉर्मरला कनेक्ट केलं जातं. ओके, म्हणजे ऍक्च्युली विंड जो इथं अवेलेबल होणार आहे, म्हणजे जो काय माझं इथं विंड स्टेशन म्हणजे जो काय विंड पॉवर आहे, जे काही इथं वारा येणार आहे ते विंड इथं अप्लाय केल्यानंतर काय करणार, टर्बाईन फिरायला लागेल. म्हणजे इथं ब्लेड्स ऍक्च्युली ब्लेड्स वरती इम्पॅक्ट होणार आहे. हा ब्लेड्स फिरल्यानंतर काय होईल, हा ब्लेड्स इट इज कनेक्टेड टू द रोटर. ओके, म्हणजे काय होईल, रोटर एकदा फिरायला लागला तर काय होईल, हा रोटर माझा गिअर बॉक्सला कनेक्टेड आहे ना. सो गिअर बॉक्स फिरायला लागेल तर काय होईल, जनरेटर फिरायला लागेल आणि जनरेटर विल स्टार्ट टू प्रोड्यूस इलेक्ट्रिकल एनर्जी. ओके, and now whatever the energy which is produced by the generator, now it is connected to the transformer or any grid system or any power system through the power cables. This is nothing but a power cables. Okay, so again this is simply blade, rotor, the gearbox, generator. Again, now the controller, I specified the name, the controller, it is shown in the previous page as a control system. Okay, control system is nothing but a controller. As the name indicates, controller, it controls the whole operation of the wind power plant. म्हणजे नाव आहे कंट्रोलर बेसिक काय, हा पूर्ण विंड पॉवर सिस्टीमचं किंवा विंड पॉवर प्लांटचं कंट्रोल किंवा कंट्रोल मेकॅनिझम हा कंट्रोलर तुमचा पार पाडणार किंवा कंट्रोलर तुमचं पूर्ण सिस्टीमचं वर्किंग कंट्रोल करणार. ओके, सो controller has a different applications, different working principles. Now इथं जे दिलेलं म्हणजे as shown in the rotor, blades, controller, generator, as well as there are a lot of different parts. Again nacelle, okay, हा nacelle म्हणजे काय, तुमचा बाहेरचा जो बॉडी आहे किंवा पार्ट आहे, इट इज कॉल्ड एज अ nacelle, as well as the brake. आता ब्रेक का लागणार आहे, what is the need of brake? Now you can show in this figure. Now this brake is connected to the generator. म्हणजे हा तुमचा रोटरचा शाफ्ट आहे, तुमचा गिअरबॉक्सला कनेक्ट आहे, गिअरबॉक्स तुमचा जनरेटरला कनेक्ट केला थ्रू द डिफरंट गिअर सिस्टम अरेंजमेंट. As well as we are applying the brake. What is the needs of brake? Suppose due to any reason, suppose the input wind speed is more and more. ओके, म्हणजे एकदम खूप वारा यायला लागला. ओके, देर आर आय एम एक्सप्लेनिंग द टू कंडिशन्स. म्हणजे काय होईल, सपोज नॉर्मली माय विंड पॉवर प्लांट इज ऑपरेटिंग ऑन द 10 to 15 मीटर पर सेकंड इनपुट विंड स्पीड, म्हणजे 10 ते 15 मीटर पर सेकंड. ओके, ह्या इतकं जर माझं विंडचं स्पीड असेल तरच तो विंड मिलला अप्लाय किंवा विंड मिल तुमचा रन केला जातो. मग काही वेळा काय असतं की बेसिकली काही वेळा असं घडतं सिस्टीमला की खूप जोरामध्ये जर वारे फ्लो होत असेल किंवा एअर फ्लो होत असेल, त्या केसमध्ये माझा विंड ब्लेड मी चालू ठेवू शकत नाही. ओके, देर आर बिकॉज अगेन देर आर लॉट ऑफ इश्यूज आर देअर. सो इन दॅट केसेस I want to stop my generations. Okay, I want to stop my wind rotation of wind blades. In that case, I should apply the brake. ओके, म्हणजे ह्या ब्रेक अप्लाय केलं तर काय होईल, इन केस जर माझं खूप इनपुट जर विंड समजा एखादं वारं असेल किंवा जर आपण केस इन केस मध्ये वादळ किंवा जर स्टॉर्म्स क्रिएट झालं, ओके, स्टॉर्म्स म्हणजे वादळ क्रिएट झालं तर काय होईल, त्या केसमध्ये मला विंड मिल चालू ठेवून चालणार नाही. ओके, कारण काय होईल, ते विंड मिल वादळामध्ये मे बी तिथं काहीतरी मे बी मेकॅनिकल नुकसान किंवा मेकॅनिकल इंजुरी होऊ शकतं. सो टू अवॉइड ऑल दीज थिंग्स वी आर अप्लाइंग द ब्रेक. ओके, ही फर्स्ट केस झालं. सेकंड केस म्हणजे काय, एक सपोज इनपुट वारा खूपच कमी आहे. मी काय सांगितलं, माझा आयडियल गोष्टी काय, आयडियल मला 10 ते 15 मीटर पर सेकंड मला विंडचं स्पीड पाहिजे, बट तितकं जर मला मिळत नसेल, मला 10 ते 15 जर असेल तरच मला विंड मिलचं ऍप्लिकेशन किंवा विंड मिलचं इफिशियन्सी जास्त मिळू शकते. जर त्याच्यापेक्षा जास्त स्पीड असेल किंवा त्याच्यापेक्षा जर कमी स्पीड असेल, म्हणजे स्पेशली दुपारीच्या वेळेला बऱ्याचसा विंडचा स्पीड कमी असतो किंवा वाऱ्याचा वेग कमी असतो, त्या केसमध्ये काय असतं, वाऱ्याचा वेग कमी असल्यामुळे तिथं मला पॉवर प्रॉपरली जनरेट करू शकत नाही. म्हणजेच 10 to 15 मीटर पर सेकंडच्या खाली असेल किंवा अबो असेल, इन दॅट केसेस आय कांट ऑपरेट माय विंड मिल फॉर better operations. Okay, in that cases I should apply the brake mechanism or braking mechanism so that my wind blades or wind turbine does not rotate. Okay, again this one, this anemometer, it is nothing but a sensor which is always senses the direction of wind as well as the स्पीड ऑफ द विंड, इनपुट विंड, म्हणजे जो इथं विंड येणार आहे, जो काही इथं वारा येणार आहे, त्या वाऱ्याची दिशा किंवा डायरेक्शन एज वेल एज त्या वाऱ्याचा स्पीड किंवा वाऱ्याचा वेग किंवा स्पीड हा अॅनेमोमीटर हा चेक करा. दिस इज नथिंग बट अ सेन्स, इट ऍक्ट एज अ सेन्सर्स. अॅनेमोमीटर इज नथिंग बट अ सेन्सिंग डिव्हाइस which senses the direction of wind as well as the speed of input wind. Okay, now according to that, this anemometer, the anemometer senses the direction of wind, and according to that this whole structure will get changed. For example, suppose now for this structure, suppose आता माझा एक विंड मिलचं डायरेक्शन, सपोज माझं विंड मिल सपोज पूर्व दिशेला, मी आता विंड ब्लेड मी प्रोजेक्ट केला की विंड ब्लेड आता नॉर्मली पूर्व दिशेला आहे. ओके, आणि सपोज जर मला आता उत्तरेकडून वारा येत असेल, ओके, सो इन दॅट केसेस माय विंड ब्लेड्स और दिस पर्टिक्युलर स्ट्रक्चर, it is changed to the position towards the north direction. Previously it was in earth, it was in east position, east direction, but suppose my input wind is coming from the north direction, then my whole system will directed towards the north direction through, and this mechanism is possible through the yaw drive as well as the yaw system. Okay, हा यॉ कंट्रोल YAW म्हणजे यॉ ड्राईव्ह किंवा यॉ मोटर हा काय करतोय, तर ऍक्च्युली अॅनिमोमीटर काय करणार, माझी डायरेक्शन ऑफ विंड डिटेक्ट करणार आहे. म्हणजे कुठल्या डायरेक्शननी माझा वारा यायला किंवा विंड यायला लागलाय, त्या प्रपोर्शनल हा काय करणार, इथं सिग्नल देणार आणि हा पूर्ण तुमचा स्ट्रक्चर त्या डायरेक्शनला चेंज होणार. म्हणजे लक्षात आलं का, मला काय सांगायचं लक्षात आलं का बघा. म्हणजे सपोज तुमचा विंड मिल सपोज आता पूर्वेकडं, समजा विंड ब्लेड्स आता पूर्वेकडे आहे, आणि सपोज आता अॅनेमोमीटर सेन्स केलं की बाबा आता वाऱ्याचा वेग माझा उत्तरेकडून यायला लागला किंवा दक्षिणेकडून वारा आता जास्त फ्लो लागला, तर माझी ही दिशा पूर्ण दक्षिणेकडे मला मर्ज किंवा मूव्ह करायचं आहे. हे कोण करणार आहे, सेन्स करा अॅनेमोमीटर. आणि अॅनेमोमीटर काय करणार, हा यॉ कंट्रोलला किंवा यॉ ड्राईव्ह, हा यॉ कंट्रोल म्हणजे काय, हे फक्त वरचं सिस्टीम हा चेंज होणार अकॉर्डिंग टू द इनपुट डायरेक्शन ऑफ द विंड. Okay, input direction of wind, it will changes. Now this one, okay, this yaw system, okay, this yaw controller, this controller is a different, this controller is for this one, okay, this yaw controller always chooses the direction of the blade according to the input direction of the wind. म्हणजे जशी माझी वाऱ्याची दिशा आहे त्या प्रपोर्शनल हा माझा जो विंडचा ब्लेड हा तिकडं, म्हणजे आता सपोज मी सांगितल्याप्रमाणे सपोज माझा वारा जर पूर्वेकडून येत असेल आणि माझा विंड टर्बाइन सपोज माझा दक्षिणेकडे आहे, तर वारा पूर्वेकडे हा सेन्स कोण करणार, तर अॅनिमोमीटर सेन्स करणार. ओके, हा अॅनिमोमीटर काय करेल, इट विल सेन्सेस द डायरेक्शन ऑफ विंड as well as the speed of wind, okay, and gives instruction to this particular system. Now it gives signal to the yaw controller, yaw, yaw, yaw controller. Yaw controller basically includes the yaw drives as well as the yaw motor. Okay, now according to the input speed as well as the input direction, this whole system is directed towards the input mechanism or input wind speed. Okay, so these are the nothing but the main parts, or simple called the basic part of any wind power plant. It includes, as I said earlier, blade, rotor, brake, braking mechanism, gearbox, generator, controller, anemometer. This nacelle means it's a outer body. Yaw control we called the yaw drive as well as yaw motor, power cable, and this is nothing but a tower. Tower means, as I showed earlier, this one. Okay, this one is nothing but a tower. Okay, so here this is nothing but a wind blades. This is including this total hub. जो part is called a nacelle. Inside the nacelle there are different parts, and this is nothing but a wind tower. Normally, the height of this particular system, it may be as of 20 meter. That means 60 to 70 feet height is always there, according to the wind speed. Okay, and again the whatever the generator already were placed here, okay, and whatever the generator electricity we are taking towards the ground through the power cables, as I shown in this figure. This is power cables. Actually through the power cable we are taking the input of what the generator power towards the transformer. Okay, again this is the detail of the wind blades. Okay, so again the direction of wind is there. This is the rotor pitch, that means its blades are there. Okay, so this rotor, it is connected to the generator. This is part of generator. Okay, म्हणजे ह्या फिगर मध्ये it is now looking towards outer direction. Okay, म्हणजे हे फ्रंट साइडला, इथं हे बॅक साइडला दाखवतं तुमचं. ओके, म्हणजे इथं काय झालंय, हे तुमचं इकडच्या साइडला रोटरचं ब्लेड दाखवतोय. ओके, म्हणजे सपोज दिस नॉट बटन वन साइड, दिस इज अपोजिट साइड. Okay, the rotor side here, pitch are there, the wind direction is here. So this is this nothing but a gearboxes. Now it is gearbox is connected to the generator. Okay, again this is the controller, anemometer, as I said earlier, anemometer, wind vane. Okay, wind vane is nothing but it is for sensing the direction of the wind, as well as a nacelle, high speed shaft, yaw motor, its tower, yaw drive. Okay, yaw drive, simply yaw controllers are there. According to the yaw controllers, yaw drive as well as yaw motors are there. Okay, simply wind power station means exactly what? It converts the kinetic energy of wind first into mechanical here, and once the mechanical energy is producing in the rotor, it is now converted into electrical energy through the generator, and whatever the generator electricity, it is again provided to the system through the power cables. Okay, so these are the basic parts as well as the working principle of the wind blade system. Okay, so then we will move towards the advantages of the windmills. Okay, the first is nothing but a wind energy is renewable and sustainable. Renewable म्हणजे पारंपरिक, पारंपरिक, and sustainable म्हणजे फिक्स आहे किंवा विश्वासार्ह. Okay, the wind is both a renewable and sustainable resource. Unlike reserves of fossil fuels such as coal, oil and gas, it will never run out. म्हणजे always wind हा तुमचा naturally free of cost available आहे. There is no any charges, or suppose you are using the different wind energies, then we can preserve, we can store the fossil fuels as well as the coal, as well as the fossil fuel coal. Okay, we can reserve it. Okay, we can save it. This makes wind turbines a viable options in helping to meet our future energy demands. Second one, it's good for the environment. Okay, wind energy is one of the most environmentally friendly energy sources, known to the man. This is based on the simple fact that wind turbines don't create pollutions. As I said earlier, there is no any combustion of fuels are there. There is no any production of the gases are there. There is no any requirement of any coal or oil or gases. So it is nothing but it's environment friendly. There is no any creation of the pollutions. थर्ड वन इट रिड्युसेस द फॉसिल फ्युएल कन्झम्पन. फॉसिल म्हणजे जीवाश्म इंधन जे आहे ते बेसिकली कोल असेल किंवा एनी जे डिझेल असेल किंवा एनी गॅसेस असेल इट विल रिड्युसेस द युजेस ऑफ द फॉसिल फ्युएल्स. Okay, that means generating the electricity from the wind energy reduces the need for us to burn the fossil fuels. This is not only reduces carbon emissions but also helps to conserve dwindling supplies of the earth's natural resources. As a result, reserves of fossil fuels like coal, oil and natural gas will last much longer. Next, again, wind energy is free. As I said earlier, there is no any cost, there is no any transportation cost, there is no any running cost because wind is available freely in the nature. Next, both industrial and domestic wind turbines are available. This wind turbine we can use for industrial application as well as for small domestic applications. That means both applications, for both purpose we can use the wind turbines. Next one, wind energy can provide the power to remote locations. Suppose my any industries which is located in the any remote location, खूप लांब लोड सेंटर पासून लांब आहे, remote location suppose कुठला लोड असेल, then for that providing the wind for providing the electricity we can use the wind power station, and in that cases the wind power station is the most effective, most efficient power generation sources for that particular remote locations compared to any other locations. Wind turbine can play a key role in bringing the power to remote locations. This can benefit everything from small villages to remote research facilities. It might be practical to or too expensive to connect these locations up to the main electricity supply. In such cases, wind turbines may have the answers. सपोज मला कुठेतरी माझं सपोज मला इंडस्ट्री सपोज कुठेतरी एखाद्या कुठे रिमोट लोकेशन उभं केलंय. सपोज मी एक्झाम्पल कुठेतरी हिली एरिया म्हणजे कुठेतरी डोंगराळ भागामध्ये सपोज मी इंडस्ट्री मी एस्टॅब्लिश केले आणि तिथं मला जर इलेक्ट्रिसिटी पाहिजे असेल तर जे नॉर्मली इलेक्ट्रिसिटी सपोज मी हायड्रो पॉवर स्टेशन म्हणलं किंवा न्यूक्लिअर किंवा थर्मल मधून तिथं बरं मला प्रोव्हाइड करत असेल तर तिथं बरं मला ट्रान्समिशन लाईन कॉस्ट येणार आहे, ट्रान्सफॉर्मर सगळं इन्स्टॉल करायला लागेल. तर कॉस्ट ऑफ ओव्हरऑल सिस्टम गोज ऑन इन्क्रीजिंग. Okay, so in that cases I can prefer the wind energy or wind power plant so that all the cost of the erection of the power system will get reduced. Again, wind technology becoming cheaper because it is available freely. Next one, wind turbine are low maintenance compared to any other maintenances such as thermal power stations. The maintenance cost of the wind turbines or wind power plant is always lower. Next one, wind energy has a low running costs. Okay, or simply called a low running charges as compared to the nuclear power stations as well as the diesel power station as well as the thermal power station, simply called TPS. The running cost or simply called as the running charges of the wind power plant is always lower than that of the thermal nuclear power plants. Okay, so these are the advantages of the wind power plants. Okay, along with this there are again this is actually these are the disadvantages. Actually, I mentioned the advantage, but actually these are the disadvantages. The wind fluctuates. The wind turbines are expensive. Wind turbines pose a threat to wildlife. Wind turbines are not. That means what? Now here these are the disadvantages. Then fluctuation of the wind and good wind sides. The fluctuation of winds means काय तर wind जो वाऱ्याचा वेग आहे किंवा वाऱ्याची दिशा आहे it is always going to changes with respect to time. म्हणजेच कुठल्याही विंड मिलला the wind will never get a constant speed. Input is never constant. It depending on the different environmental issues, the wind power speed as well as the wind speed as well as the direction of wind, it depends. Okay, there is always fluctuation. Fluctuation म्हणजे काय तर changing. Okay, म्हणजे स्थिर नसतं, कॉन्स्टंट नाही. Wind power stations are always fluctuations. Okay, these are the main disadvantages. Wind energy has a drawback that it is not a constant energy sources. Although wind energy is sustainable and will never run out, the wind isn't always blowing. This can cause a serious problem for wind turbine developers who will often spend significant time and money investigating whether or not a particular site is suitable for generation of wind power. For a wind turbine to be efficient, the location where it is built need to have adequate supply of wind energy. That means what? Now, always I know that the input wind is never constant. Okay, it is always changing. It is called, it is not always fluctuating conditions. Okay, so in that cases, while erection of the any wind power station, the selection for this location for a typical wind plant, it is always a typical one. That means there is a lot of researches or a lot of studies to be required for selection of any site for particular wind power stations. Again, second one, noise and acoustic pollution. Always, whenever in the running condition, wind turbine generates noise and visual pollutions. Okay, that means a single wind turbine can be heard from the hundreds of meters away. Although steps are often taken to sight wind turbines away from the dwelling, many people cycle look of wind turbines, others do not see them as a blot on the landscape. That means always in the running condition, there are a lot of noises are produces by the windmills or wind blades. Again, not a profit. Third one is not a profitable use of land. Alternative uses for the land might be more highly valued than electricity generation, because for choosing the different location for the windmill, generally it is located on the hilly areas, and it depends on the different wind speed as well as wind speed and the different environment issues. And for that, the selection of the land, it is always a non-profitable one. And last, third one, it's a threat to wildlife. Birds have been killed by flying into spinning turbines out there. बेसिकली जेव्हा तुमचं विंड मिल टर्बाइन जो रोटेट होत असतं, इट विल क्रिएट द थ्रेट्स, म्हणजे भीतीदायक वातावरण क्रिएट होतं बिकॉज ऑफ द रोटेशन ऑफ द टर्बाइन्स. ओके, बेसिकली बऱ्याच वेळेला त्या विंड ब्लेड्सला धडकून बरेचसे बर्ड्स आहेत किंवा पक्षी ते मृत्युमुखी पडलं जातं. However, it is believed that wind turbine pose less of threat to wildlife than other man-made structures such as cell phone mast and radio towers. Okay, basically because of the rotation of the wind blades, maybe तिथं पक्ष्यांना किंवा आणि जे flying जे animals आहेत, it will causes their injuries for that particular systems. Okay, so these are the advantage and the disadvantage of the wind power plants. Okay, apart from that, we are always know that wind power station is one of the renewable as well as sustainable energy sources. Okay, so depending on the applications, we can choose either we can select the wind or we can go for the any other sources. Okay, so that's it for this lecture. So in the detailing, next lecture we will see about the how exactly the wind blades operates. Okay, thank you.